Okay, if you've been following this series, you've seen that we've had a video on what electricity is, and then we made this little circuit. And in this circuit we have the light bulb, but I want to change that. I want to take that light bulb out because that light bulb at 4 or 5 volt rating light bulb, I think you could go up to 10 volts with it. It's more than we need. This light bulb is more than we need. It consumes a lot of current from the battery, which is going to drain the battery quicker. To avoid that, they have created a little thing called a light emitting diode, or LED for short. And this is one of them. And this is going to be bright enough for us to see that our circuit is on. We don't need that big light. But there's an issue with LEDs. You see how small it is compared to our big bulb. Pretty big difference in size. It also, with that, does not need 9 volts to operate. Most of these can run anywhere. They can go up to 9 volts. They can go all the way down to like 1 volt. So if we put too much voltage through this LED, we could damage it. And I have done that. This one is really tiny for a LED. Some of them are smaller, some of them are bigger. This one's on the small end. So I don't know exactly the part number of this LED. I have no idea what to look up on a data sheet. But you can look at data sheets and see that it gives the maximum tolerance and minimum tolerance of these LEDs to light up. I got a 9 volt battery. I'm going to want to reduce it in the beginning down as low as I can get it, and then work my way up till it starts lighting up. We're going to use the multimeter. And we need to, the way I would start this out is with a very high resistance. That's where this component comes in. So we have an LED. Our new components for this circuit is the LED and a resistor. And we'll learn about both. So I have my ohm meter, my multimeter here, set up for ohms in this right here. And I'll put it up. We don't know the range that this resistor is. There's a way to tell. We'll introduce that a little later at the end. Okay, so I need to know how much resistance to put in this to keep that LED from burning out. So I've got some randomly picked resistances here, a few that I'll work on. I want a real high resistance, so I'm going to start with the highest I could. I would like to start with a mega ohm because I know that's going to be too much, but I don't know it for sure. If you're new at this, you're not going to know. You'll have some intuition. If you've done this a while ago, well, I need a resistance about this. But if you're brand new to this, you don't know. I'm assuming you don't know. We're going to assume I don't know. So I'm going to just randomly pick a resistor. We're shooting for about a mega ohm and see if that lights up that diode. Okay, this one says like 1 kilo ohm. Let's drop this down there and see. Now it's 0.8 kilo ohms. So we're going to say this is, about 0.84 kilo ohms. So that is not even where I want to be on mega ohm. Let's look at some other one. Let's look at this big guy here. He's pretty big. He's over. He's going 24 kilo ohms. That's a lot better. 24 kilo ohms. We're going to set this one down here by the battery because we want to use it. Maybe. Let's try this little guy here. I don't know how he's going to do. He is 34 kilo ohms. The decimal point is there if you can't see it. I'm on the edge of my table there, but it's 34.6, 34.5 kilo ohms. So he was pretty high. We might use one of these two. Now we have this one here. He's real little. Well, let's see what he does. He's over range. Let's put him up here. Now we've changed to mega ohms over here. This is half a mega ohm. That's getting closer. Maybe I'll use that one to see if that can light up our LED. But this is a good time to introduce something about resistors, since that's one of our new components in this circuit that we want to discuss. If you take two resistors and hook them end to end, we call that series because they're in series, one after the other, and you hook them in series, you would clip these extra off. They add together. So if this, let's say this is 100 ohms, this is the same kind of resistor, it'll be 100. Let's say they're both the same. They don't have to be. Well, let's say this is 100 and this is 300. Then you're going to have a 400 ohm resistor. Whatever they are, the sum of the two together, you could put a third one on and add it into the rest and just keep going. So we have this. We had a half a ohm resistor. Let's just say that this resistor, it looks like the same kind. So let's just say that this resistor is the same as that. If it's about a little over a half a mega ohm, we should get, or a little over half a mega ohm, we should get a mega ohm out of this. We check it and he wants just under 0.7 mega ohms, whereas before it was 0.44, jumping around there, for 0.44 mega ohms. So that's as close to a mega ohm as I care to go. I don't need it exactly because I'm pretty sure a mega ohm is not going to light up that LED, that light emitting diode. The LED has, one is called a cathode and the other one is called a anode. And the cathode goes to the positive side of the battery. A diode accepts current in one direction. It'll accept DC current either through this lead first or through this lead first. So it matters, it's polarized. It matters if we put it in this way or this way. How do we tell? If you look on the data sheet, you'll see that sometimes the longest lead is the cathode and sometimes the shortest lead is the cathode. Most of them show the shortest lead as being the cathode. If it doesn't light up, we can flip it around and try again. I'm going to just guess and put this shortest lead slightly shorter. That's another problem. If you salvage your parts, it could have been clipped off. They could have mounted it into a board and then clipped off the longer part, and that's why they're so close to the same. But we're going to go with the longest one, slightly longer, it's this one, to the positive lead. So we'll stick the shortest lead under our little tape here to ground, and then we'll take be sure our switch is on, and then we'll take our resistor here, a resistor chain here, and try and light up our resistor. And he doesn't light up. Can be two reasons: too much resistance at a mega ohm, or we have the LED in backwards. We don't know which one yet. So there's our mega ohm. Let's look at the next lowest one, which I think was 34 kilo ohms. Still didn't light up. Okay, let's go lower. We had 24.1 kilo ohm. Let's see if that one works. If you're an electrical engineer and you have your data sheet, you'll be able to do the math and just figure this out real quick. Interesting. Let me shut off my light here so you can see that. And let's zoom in a little bit on this guy here. He lights up. I don't know if you can... Yeah, he lights up. In the camera he looks pretty bright, but you can actually barely see it. So that one is too high of a resistance. So we now know one thing. What do we know? We know that our LED is in the right way. Here's the 0.8 k ohm. Ooh. Now he lights up pretty good. And I don't think he lights up too high. Let's turn our light back on. And you can see him. This is just plain light lit room. I think we're going to go with him. I don't want to go too much brighter because I don't know, he's kind of white, he should be red, so it may be a little bit too much current. We might be able to drop this down, but I think we're going to go with this resistor. So we take this resistor and we are going to solder him to the switch and to the LED, thus replacing that big light with our LED. So we know we have it in the right way, and we've got approximately the proper resistor to light it up. And when we get it checked in, we can check how much voltage is going through there, because is what resistors do is they limit the current that goes through them. So you use them to reduce current into a circuit so it's at the right current you want, or the right voltage. Let's see how well I can do this. To see if your solder joint is strong enough. Yeah, it's pretty strong. The solder joint stayed. The rest of the stuff didn't fare so well, so it's pretty dang strong. Now there's some precautions here. Remember from our last video we said that this steel plate, this metal plate, is our common ground because our battery's ground is connected to it. So we don't want in here, we want to make sure that this, and we demonstrated it in the last video, we don't want this touching the plate, otherwise you have a short. We don't want anything grounded along this leg of the circuit until it gets past the diode. Gets past the diode, we want it grounded. If you're afraid of this getting grounded, you can always slip a small tab of paper under right here, like that. But you would just use a small one. That'll keep it. Part of the tape will keep it too. And now if we turn this on, we have our light emitting diode emitting light. From here on out, concerning this circuit, I will let you know what the next component or components we will be using, so you can look for them if you're keeping up on this circuit and building it as we go along. That way you can get them before watching the next video. So in our next video, we'll be adding an electrolytic capacitor like this one. Please note that this is a 10 microfarad capacitor. And we'll talk about microfarads later, but it's a 10 microfarad. I hope you enjoyed this video, and please like and subscribe. Thank you for watching.